Hello there! In this video, we will talk about framerate independence and delta time in pygame. Now, this isn't a topic that's easy to visualize, but for what it's worth, here's what we are going to make in this tutorial. A sprite that moves left and right with a rotation and an animation. Now, that's not anything impressive, but the special thing about it is that this animation runs at basically any frame rate, which is something that is really important for basically any video game. Now, before we can talk about how to create this, let's talk about some theory first. If you make any kind of game, you want it to be consistent at all times and for every device. But the problem is that players have very different kinds of devices. So some players have really good computers, other players have really old and weak ones. And in practice, that means that you might have one player with a really good PC that runs your game at 600 frames per second, whereas another player might have a really old computer that can only run 30 frames per second. And you want both of these players to have the same experience in your game. And also, even on the same computer, there might be different parts of the game that might be more demanding than others. For example, in Elden Ring, this is actually an issue right now, where the game runs really smoothly inside of a dungeon. But if you're inside of the overworld, the game tends to slow down once in a while, which is something players are really unhappy about. So what you really have to make sure is that you always account for any kind of frame rate. And let's do some math on this to illustrate what the problem here is. We have different frame rates, or frames per second. We have 10, 30, 60, 120, and 600. And then we also have some kind of object that moves at a certain pixel speed per frame. In my case, it's always going to be 10. So this could, for example, be a player that moves 10 pixels to the right on every single frame. And this could either be different devices or the same game in different circumstances. So like I've said just now, Elden Ring might be running 60 frames inside of a dungeon, but in the overworld, we might only get 30 frames, which would be a very different experience. So essentially, what we have to do is multiply, and then we get different pixels per second in terms of movement. And here you can already tell the massive differences, that if our frame rate is 10, we're moving at 100 pixels per second, but if our frame rate is 600, we are moving 60 times as fast, which would essentially break any kind of game. So these differences here are a terrible problem for your game. And if you didn't account for them, the game would essentially be unplayable. So how can we fix that? And there's one easy-ish solution, and that is that you can limit the maximum frame rate. Elden Ring actually does that. That without a mod, Elden Ring at the most runs at 60 frames per second. But this approach has two major downsides. Number one is that it does not account for the game running below the target frame rate. So if we are dropping down to 10 frames per second, this approach would break down. And besides that, possibly even more important, is that you want a high frame rate, because it will make the game look and feel much better. So if you have a higher frame rate, you will draw significantly more frames for the game, which will look much smoother. And on top of that, you will also check player input, physics, collisions much more often, which will give a more responsive feel to the game. So limiting the frame rate by itself isn't good enough. There's one more thing that we do need, and Elden Ring does this one as well. And what it does is it uses delta time for consistent speed at all frame rates. Now, what does that mean? Essentially, delta time is the time difference between the current and the previous frame. So literally how long it took our computer to draw the current frame. And this information then we're going to multiply with any movement inside of our game. And that will make the game run smooth at literally any frame rate. It sounds a bit like voodoo magic, but it works really well. And let's do some math to illustrate what's happening. Let's say we have a game that runs at 60 frames per second. And from that, we get a delta time of 1/60, or 0.01666 and so on. And this we're going to multiply with our movement and our frame rate. So if again we get our movement at 10 and our frame rate at 60, we get a movement of 10. And this by itself doesn't sound too impressive. But now let's do a second example, that we have 30 frames per second. Now for this one, our delta time is going to be 1 over 30 or 0.0333. Now if we do the same math again, with a movement of 10, a frame rate of 30, and a delta time of 0.03, we are also getting 10. So our pixels per second outcome is identical for two different frame rates. And as a matter of fact, I can do the same math for all our previous examples, and we would always end up with 10 pixels per second regardless of the frame rate, which is exactly what we wanted. Now, before we are going to implement this, there are a couple of things you have to be aware of. First of all, when you use delta time, you have to multiply any movement with it. So literally any movement, any rotation, any animation, literally anything that moves needs delta time. And besides that, you are also going to need much larger numbers to move things. That's arguably quite a simple thing to implement, but if you move 10 pixels per second, it really isn't all that much. So just keep that in mind. Now we are almost there. The last thing we need is that in pygame there are two different ways to get delta time. The first approach is to use clock.tick. And this one you have probably already seen in pygame. It is usually used to limit the frame rate, but it also returns our delta time. So we can get it from here. And this is a very easy way, but it's also not as precise as it could be. And you do want precision in your game. It's generally a good thing to include. So I generally wouldn't really recommend using this approach. A better one would be to use the time module in Python. And this one is already included in Python, so you should already have it. And I'm going to explain the code in just a second. But essentially, this is a slightly more complex but a significantly more precise approach. So this is the one we are going to go with. And there is going to be another issue, but let's jump into the code and let's actually implement this and see how far we get. So here we are in a very simple setup. Let's actually run it and see what we get. All we can see right now is a rectangle moving left to right, literally nothing else. And let's go over this code before we start working with delta time. At the top, we are importing the usual pygame stuff and debug. And debug is this file here. I have actually made a whole video about how this works, but basically all it does is this. In our game loop, we can call the debug function and pass in any kind of string to display it right on the window. So for example, I could write test, run this, and we can see test in the top left. It literally doesn't do anything else. It doesn't influence the game whatsoever. It's really just there to show some information. So if you don't understand this one, don't worry about it. Now for the more important stuff. We are initiating pygame and we are creating a clock and a screen. After we have done that, we are creating a rectangle with a speed. And this speed we are using further down here to move the rectangle. So what is happening down here is we are grabbing the X part of the rectangle and adding the speed to it. And once we have that, we are just drawing the rectangle. This is some very basic stuff in pygame. This shouldn't be difficult at all. And then besides that, we have our event loop. And then we have down here, we are updating the window and we are limiting the frame rate to 60 frames per second. And now to actually demonstrate where the problem is. Right now, our frame rate is defined down here. And this gives us this kind of speed if I were to run it. So if I set this to a very low number, let's say 10, and if I run this again, now our game is running significantly slower. And I could also set this number to something really high. And if I run it again now, it's way too fast. So both of these extremes would break the game. And now basically what we want to do, when we are running this line here, we want to multiply our test speed with dt, short for delta time. And for that to work, we have to get delta time. And there are two ways of getting it. Let's start with the easier one. And this one we get from clock.tick. And usually in this approach, the tick method for the clock is all the way at the top. And for this one, we can just save the value in dt. And before we actually use it, let me comment out the dt down here. And let's just print what we actually get from dt. So what I'm doing right now, I'm just passing this variable into the debug method. So if I'm running all of this, we can see we get 16, 17 sometimes. Now, what does this number mean? The tick method essentially gives us the milliseconds since the previous frame. And this is the math I have done earlier. So if you divide 1 second divided by 60, you get 0.0166, and then you continue with a lot more sixes. And what the tick method is giving us is this 16 essentially. And remember here, there are 1000 milliseconds in 1 second. Now the problem we have with this right now is that we want this value in seconds, we don't want this in milliseconds. So a number we actually want is this entire thing. We don't just want a 16 or 17, we want a 0.016 something. And this we can get quite easily. All we have to do is divide this value by 1000. And now I can uncomment dt. And now this should be working much better. So let's run it again. And now we get 0 movement. For the simple reason that now our test speed is way too low. So let's change this to something like 200. And now this should be working. So now we are getting a movement again. That is, well, you can't really see it change so far. But now what I can do is, for this frame rate here, I can set this to something like a 10. And now if I run this again, the rectangle is moving at the same speed, except now the frame rate is, well, much worse. But the speed itself doesn't change, and that's the important bit. And well, with that, we have gotten delta time. Now, this approach has one problem, and that is that it's not exactly precise. And since we're working with very small numbers, you do want precision. So a better way would be to use the time module in Python. And let's do this straight away. Now, to use this, we have to import the time module. And this one is already installed with Python, so it should work by default. And what we basically want to do, before we are starting the while loop, I want to get previous time. And what I want to get in here is time.time. And this is giving us our current time. And then inside of our while loop, let me comment out the previous clock.tick. I want to get my delta time is going to be now my time.time minus the previous time. And after that is run, I want to set my previous time to time.time. And with this approach, we always get the time between the different frames. It's ultimately quite simple. And let me add another space. So now let's run all of this. And now we can see we have a significantly longer and much more precise number, which is exactly what you want. Now the problem is that our rectangle is not moving whatsoever. And well, now you can see it's moving a tiny bit, but why is this thing not moving or moving so inconsistently? And the answer here is that our frame rate is too high. And that is not the problem that happens because of time.time. So if I comment all of this out again and uncomment the previous approach and change this to something like 600. Now if I run this, we get the same result. Essentially the problem we have right now is that all of this breaks if our frame rate is getting too high. Now, you might be asking, why is that the case? And that's a very good question. Let's talk about it. that's just going to be a tiny bit more theory. Basically, the problem is that when we use delta to move, we are always moving with floating point numbers. But with pygame, when we are placing a rectangle, we always have to place an integer. And well, what does that actually mean? Let me give an example. If we move with pure integers, let's say 5 pixel, and this could, for example, be the rectangle we have just used, and we want to move this rectangle to the right by 5 pixels. If that was the case, on the first frame, we would have 5 pixels, then 10 pixels, then 15, and then 20. This one works just as expected. So this one is totally fine. Now, where the system does break down is when we have a floating point number, let's say 4.5. So technically, this should be 90% of the original speed. So this is also a rectangle that we want to move to the right by 4.5 pixels. The problem is now, when we use this pixel information on a rectangle, pygame always has to place a rectangle in an integer position because it's pixel information. And as a consequence, this 4.5 would be truncated, meaning that this 0.5 would be omitted. And as a consequence, when we move it by 4.5 pixels, we would only get 4 pixels, and then our next frame we would get to 8 pixels, then to 12 pixels, and then to 16 pixels. So even though it's supposed to be at 90% of the speed of this initial rectangle, it is actually moving much slower. And even worse, if our framerate can fluctuate quite a bit, this number might get lower or higher, which is making our movement very inconsistent. And then what happened in our actual code? Let me go back to it. So in this one here, if I run it again, we still get basically 0 movement. Sometimes we get a tiny bit of movement. And let's actually visualize the information that this rectangle here is getting. So let's print this test speed multiplied by delta time. And let me use time.times so we get more precise information. And now let's run this again. And now the number we get is 0.2 and a long number. Now pygame essentially sees 0.2 for the most part and truncates this to a 0. So the rectangle doesn't move at all. Now, very rarely, this number gets just large enough to pass a 1, very, very rarely. And this is why sometimes this rectangle is moving, but most of the time it doesn't. So I hope that explains the issue. Now, more importantly, how do we solve it? And the answer here is essentially that we don't move rectangles by themselves at all. Instead, we are storing the information in a separate variable and then set the rectangle to the position of that variable. Sounds complicated, it really isn't that bad. So below my test rect, I want to set, let's call it test rect position. And by default, this is going to be test rect.x. And now in our game loop, I want to get my test rect position, and this one is going to get test speed multiplied by delta time. And now for the test rect position, I want to set this test rect position for the x part of the rectangle. And important here, this should be equal, not plus equal. So now if I run all of this, now we have a very smoothly moving rectangle. This feels much better. And this works at literally any kind of frame rate. So right now our frame rate is literally unlimited. So this is working really well. Although there's one more thing that I would like to do. That this test rect position should get a rounding. And the reason for that is, let's say right now this test rect position is 1.6. If we were to just pass this into the position of test rect.x, pygame would turn this 1.6 just into a 1. And it would essentially remove this 0.6. Now the problem is this isn't as precise as it could be, because the more precise location here in terms of pixels would be a 2. So we don't want to truncate this value, Instead, we want to turn it into the integer that's closest, which in this case is 2. And for that, we are using round. Although in practice, you don't really see that much of a difference. So if I run all of this now, well, we get essentially the same outcome. But now this is looking really smoothly. So with that, we have a very basic setup on how to use delta time and basically any kind of frame rate. Now the question is, how do you actually implement this in a more complex project? And for that, we have the second example. And the more complex example is going to be this one. So if I run this code here, we can see a pirate that's moving left and right, that rotates, and that has an animation, which is basically all the stuff you want to do in a game. And if I close this, we have a couple of lines of code that should all make sense. I guess let's go really quickly over the main parts here. We are importing the usual stuff plus time. Then we are setting up the pygame window, just as we have done before. Then we are creating a sprite. I'll explain this one in just a second. After we have done that, we are creating a group and placing one instance of this sprite inside of that group. After that, we are starting our while loop and we're getting delta time with time.time, basically what I've just explained. Then we have our event loop, we are filling the screen, then we are updating and drawing the sprite group. And finally, we're updating the window and limiting the frame rate. So all of this should be fairly simple. But now we have the same problem, that if I change the frame rate to basically anything besides 60, this entire thing breaks. So at 600, this thing becomes basically unplayable. And if I set this to something like 5, it becomes incredibly slow. So this is what we have to work on. And for that, we have to update our sprite. So let's have a look at this one first. We are starting with our init method. And in here, we first import a couple of frames and set a frame index. And this one will be used to pick one of these frames. We are actually doing this straight when we set the image, but we're also doing this down here in the animate method. And this one here would be a really simple way to animate a sprite. If you have no idea how this one works, check out my introduction to pygame. It explains all of this in quite some detail. Once we have that, we are setting self.rect, and this one is in the mid left of the window. And then besides that, we have a couple of attributes for the rotation, the direction, the move speed, and the animation speed. So this is basically what moves and rotates and animates our sprite. And how these things are going to be used is a bit further down here. So besides our animate method, we also have a move method that right now just moves the rectangle to the right in a direction by a speed. And then if this rectangle gets too far to the right or too far to the left, we are changing the direction. And for the rotation, we are simply increasing the rotation, and then we're using pygame transform row to zoom to rotate this image. And then in our update method, we are, well, calling these three methods here. And now, basically, all we have to do is apply delta time to all of these methods. And for that, first of all, we have to make delta time available inside of the update method, which is quite easily done. So when we call the update method, I want to pass in delta time in here. And for that to work, the update method needs another parameter that I am also going to call delta time. And now each method that moves anything needs a delta time argument. And since we have now an argument, we have to create some more parameters that are all going to be called delta time. And let's just run the code to make sure nothing went wrong. Cool, still works. And let me set the frame rate, let's say to 600, so it's a bit easier to see what's going on. So right now, all of this is going to be way too fast. And the most obvious problem right now is the move method. So this one works way too fast. And in here, we could just multiply this line with dt, which right now would, well, make the movement basically 0. And that's the problem I just talked about, that pygame is truncating this number. So anything like 0.2 would become a 0, so our movement would be a 0. And to fix that, I want to create another attribute in the init method that I have called self.position. And this one is going to be pygame.math.vector2, that needs to be capitalized. And the position at the start is going to be self.rect.top_left, essentially the top left of this rectangle. Now we are not going to move this rectangle, instead we are going to move the position. So self.pos.x is going to be plus equal all the stuff we have just done. And now the rectangle x position is going to be self.pos.x with the slight modification that this value is going to be rounded. And right now our rectangle is only moving left and right. But if you also had vertical movement, you could just add a y to both of these values and you would address this part as well. So now if I run this, we can see we still don't have much of a movement, but now the reason is that our move speed is very, very low. So if I set this to something like 200, now this should be working. And there we go. Even though we have a move speed of 200, this thing is moving at a reasonable pace. And just to see if this is working with other frame rates as well, let's change this to, let's say, a 30. And let's try this again. And now we have the same move speed, except now the difference is our rotation and our animation are much, much slower. But the move speed does not change. So with that, we have addressed the first part. Now, next up, I guess we can work on the rotation. And all we have to do in here is to move the rotation plus equal 1 multiplied by delta time. And now we also have to increase the rotation number. Let's say 50. And now if I run all of this, we have a movement and the rotation is significantly slower, even though our frame rate is still at 600. And well, this is working really well. Now the last thing we have to address is animate. And this one also is kind of simple, because all we have to change is the animation speed here. And this one, I'm just going to multiply with delta time. And now we also have to increase the animation speed here. So let's set this one to 5. And now, it may be a tiny bit too slow, but I think generally you get the idea. This is working really well. And well, with that, we have our basic setup. And we can try this as well. So here we have our clock.tick, and let's set this to 30. And now we still have a similar speed, except now the entire thing looks a bit choppier. Actually, to illustrate this a bit better, let's set our frame rate to 1. And now you can see that everything is very slow, but we still keep the same speed, the same animation speed, and the same rotation. Except now we have very, very few frames. I guess a bit better would be something like 5. And there you can see it's significantly better. So now our animation, movement, and rotation speed is the same, except we're doing it with much fewer frames. And all right, so with that, we have basically covered all you need to know to understand delta time and how to apply it to pygame. So I hope that was helpful, and I'll see you around.